questions on the homework?
3.
3?
And 11.
I just want 3.
All right, Taylor's throwing her tantrum, and we're moving on. On number 3, I will tell you this because you won't see these problems like this the rest of the year. This problem should be y equals 1 over the square root of 3x minus 2. If you try to do exactly just the chain rule in 2 steps, there's a third that you need because this u is actually another chain rule problem. They want to see if you can practice and do a little bit on your own. It won't be given to you like that on your test. It'll be given to you like this. Find the derivative of 1 over the square root of 3x minus 2. And the reason for that is a lot of people will just do it like this, 3x minus 2 to negative 1/2 and take the square root. So I might or might not get the answer in the back of the book, but I'll get the right answer. I'll get the same form of the answer. So when it comes to these problems, I don't really break them up like that. I'd like to look at the whole thing. And now, if you want to do the chain rule, you can get the answer. Matthew, how do you do that? No, you don't sigh like that. You just give me the first step. Yeah, negative 1/2, 3x minus 2 to negative 3/2 times 3. When I did it, I thought of the problem as y equaling u to the negative 1/2 and then u equaling 3x minus 2. So the first part was negative 1/2 u to negative 3/2, and the second part was times 3. I just put it in for u. I would rewrite the problem so you can see it clearly what's happening instead of allowing the book to dictate how you read the problem to try to do it. So that's the notes on how to do that problem, and obviously you just put in u for your expression. Okay? Great. Anything else?
11.
11? Sounds good to me. 11. All right. For number 11, I'll probably do the quotient rule, don't you think? Where I take, like, there they are, nice. F prime of x equals. The derivative of the numerator is 1. Then you have x squared minus 4, or sorry, x squared minus 1 to the 4th. Minus x times the derivative of x squared minus 1 to the 4th. I think I'll put that in a bracket, just to show you what the derivative of that expression is. So it would be 4, and then something cubed. That's the first step. And remember, when you take the derivative of the outside function, the inside function doesn't change, x squared minus 1. And now you multiply it by the derivative of the inside, which is 2x. And that's all over the denominator squared. And obviously, if you take to the 4th and you square it, it's going to be to the 8th. Good. Before I multiply everything out, I think I would factor an x squared minus 1 out to the 3rd. Remember, when you factor, you always take the least exponent that has a common base. So f prime of x, I would write x squared minus 1 cubed. And then I write in what I have left over in case there's any way I can simplify it or factor it. Eventually, you're going to be solving these, so you want the polynomials to be as easy to solve as possible. So you know this is plus or minus 1. You're left here with x squared minus 1. The 1 obviously multiplies through. Minus Yeah, that's why I underlined it. That's going to be factored out. Minus, this cubed is gone, so it leaves me with an x and a 4 and a 2x all multiplied together gives me a 8x squared. All over the denominator, x squared minus 1 to the 8th. You'll find that common if you do a lot of chain rule derivatives, that you can usually factor something out because of the exponents. So the cube's obviously going to go away. That leaves me with 7x squared minus 1 over x squared minus 1 to the 5th. Yep, negative 7x squared minus 1 all over x squared minus 1 to the 5th. Okay? What is it?
Can you take the bottom to the top by doing x times x squared minus 4 to the negative 4th and do the product rule?
Yes, but as evident by yesterday's quiz, the product rule, a lot of people didn't do well on the product rule question, but that means you'd have to factor out x squared minus 1 to the negative 4.
But it would still be done.
It'll still get the same thing, right? You're going to have to factor it out, though. Okay? Anything else? Oh, yeah, Monday. Monday you'll get him back and you'll finish part 2. Okay? If I have time, I'll let you see him today. Remind me on with 10 minutes left, I'll try to hand him back, okay? Wind things up. Anything else on the homework? Everything went all right? Ooh, look at those.
10 minutes left.
Fantastic. All right. I have no idea what to do.
Let's stop.
That actually goes from 7 to 62. Scary.
This is 3-6. 3-8, 3-7, 3-7. There we go. Let me get to some other notes that are prepared. Yep. All right. As somebody said, the last one we did was 14. So we'll pick it up after this one. Took the derivative, multiplied it, combined like terms, and got the final answer. This one, on number 18, we just did one in homework like it where we had the quotient rule in with the chain rule. Don't misunderstand the difference between the product rule and the quotient rule and the chain rule. The product rule is the way of taking two functions multiplied together. So you need two functions in the product rule, just like two expressions in the quotient rule. Hey, there you go. Two expressions needed. So in this one we have two expressions, 2w squared minus 3w plus 1 and 3w plus 2 to the 4th. The chain rule is used for taking the derivative of a composite function only. So you only need one expression for a chain rule. So this one you're going to use two expressions, so that's going to be a product rule. So when you take the derivative and the product rule, I can't believe I have to rewrite this, is say this is h and say this is g. The product rule, f prime of whatever, equals h prime g plus hg prime. That's the product rule. All right? When you get your paper back later, just to look at what you did, you're going to see that you missed it. It was a very easy product rule question. And then when I take the derivative of g, I will have to use the chain rule for that. When I take the derivative of h, I will just use the power rule for those. All right? So the chain rule is part of taking the derivative of the product. The power rule is part of taking the derivative of the product. So go ahead and get your pencils and give this a go, and I'm going to walk around and see how you do. Okay? And I'll come back up, and we'll go through it together. But I want you to give this a start on your paper with a pencil. Nice! Not feeling love, are you? You're going to feel it in a few minutes. Good. Because we're going to practice. All right. Oh, I'm supposed to give a shout out to some missing people today. Remind me to do that later. Because I don't know who's gone. Microphone's not that sensitive. That would be Stephanie, Kaylee. Oh yeah, Kaylee. Both Hannahs. E. Oh yeah, Rachel and Michelle. Oh yeah. Okay. Shout out to everybody that's gone. What did you do first, Matthew? No, what did you do first on your paper? Just read it to me. Well, exactly. 4w minus 3 times 3w plus 2 to the fourth.
Yeah.
Plus what? No. You got to take the derivative of each one. No, he didn't. 4w minus 3 times 3w plus 2 to the fourth. Plus 2w squared minus 3w plus 1 times 4 3w plus 2 cubed times 3. You forgot the times 3, I thought.
You didn't get that far.
Nah, you should have went quicker. All right.
Wow.
Did you get it? So that's what you should have got.
I don't chain rule thing. I don't understand it. I got the first part.
Which one? You got this first part where it's right there.
Yeah, and I got the next one because that's just
Right. And now when you take the derivative of this expression, they want you to think of it as u to the fourth and then 3w plus 2. You have to think of it as two different problems.
so first you take the derivative of the whole thing and then the derivative.
No, you take the derivative of the outside, which is the u to the fourth. Remember, this is in parentheses, and that's in parentheses.
And then you take so derivative outside and inside.
Right. So that's why it's 4u cubed. That's what we have right here, 4u cubed. Sure you can.
Well, you can, but are we really going to do this?
Sure. Yeah, you can take out a 3w plus 2 to the third, and that's about it. So it's not much. What do you mean?
I meant we're not going to actually do the fourth, do the third.
I don't know what you mean, but we're taking out 3w plus 2 to the third. Okay? And then take a look in here. Once you factor that out, what? Once you factor that out, you can multiply these out and combine the w squareds. Remember, you're going to be solving these. So, that's why you practice getting them down to the lowest form. All right? So you factor this out, and now you're going to multiply it out. You can easily multiply out this, 12w squared plus 8 minus 9 minus w minus 6. That doesn't take long. Oh, sorry. And then you can multiply out to 12. You can distribute that and combine everything. So that's good. You can do that. I took 3 steps to get to the derivative because I was still doing the introductory lesson for the chain rule. I wrote this. We just didn't get this far. So if the ddx's are messing you up, remember that's like a square root. It's an operator. It says you're going to take the derivative of the term immediately to the right. So to multiply it out, you end up with 12w squared minus w minus 6. 24 minus 36 plus 12. Yeah, 26w squared minus 35w minus 37 plus 6. Yeah, that's your final answer. Nice job. But you have to get to this point because you're going to solve these. And you're going to take the derivative of derivatives. So you don't want to be sitting here with a big mess on your plate wanting to work with it. You want it as neat and as tidy as possible so when you start your second round of work, you have something nice to work with. Okay? Sure I do. All right, ready? That was fun. You ready? This next one's going to be hard, I think. Well, they're all going to be difficult. They're all going to take time. But you can get better. Oh, this one's a piece of cake. Skip it. Oh, no. Oh, no. It's like a golf course. You never pass up the easy holes. They help your overall score. This one gives you confidence. Isn't that right? What'd you get? Oh, good. This gets us into the 20s. That's good. Chain rule. Do you have to use a product rule in this case? No. We need to work on that, apparently. So the derivative of the first one is the negative 2/3 and negative 5/3. The inside stays the same. And then you take the derivative of the inside and get 4z minus 9. All right. That's it. There's nothing to factor on this when you don't have an addition or subtraction sign. There's not a denominator to divide things off with. The 3 doesn't go into the 4 evenly, and you can't factor anything out of the 4 and the 9, so that's pretty much about it. Okay? Again, the common mistake on this one, people writing 1/3 instead of negative 5/3. So don't do that and you'll be fine. All right? See, this is fun. It's quiet. I like that. All right. Square root of 4x squared plus 2x plus 3. I forgot to look how far we were supposed to get today. Okay.
Please go all the way up to 63.
Perfect. Got an answer? Simplified? Yeah, it's pretty close. Only one more step. I'll go see what Vern has written down. I'm walking by ease. Did she say here? Oh. Close. One more step. Right. You'd probably take the 1/2 through. Well, 2 times a half, however you want to think about it. I don't know why that's up there. I'm not going to capture anything in the smartboard. Yeah, I think the square root obviously is to the 1/2 power. And then, so it's 1/2 times the derivative of all this, 4x squared plus 2x plus 3. And then a lot of people have this, but I would just take that 1/2 and run it through the 8 and the 2, just to get rid of it a little bit. Yes? Probably. Yeah, just 8x. So then your final answer would be the 4x plus 1.
So why wouldn't you multiply it with the left side?
Because order of operations, you have to do exponents before you do multiplication. All right? So, but you can do the half back here because there is no exponent. He asked why you couldn't run the half through here, because order of operations, you have to do the exponent first before you multiply. Oh, sorry. What was she asking? I'm good. Excellent. We're moving on. I got better news. I'll be here all next week. Yes.
Did you have to?
I called last night. I entered my 9-digit jury number, and it says I have next week off. Not to call back Thursday at 6 p.m. Okay? Next Thursday. October 6th. Is that right? October 6th. All right, ready? It's a random number, too. I can't figure out the pattern. My jury number. Well, you would think so with your address and your GPS location and all that other stuff.
There's a pattern probably in the numbers that they give you.
It could be.
There's a pattern. Unless
All right, cosine. Well, I hand back the first 2 questions, and on Monday we'll do 3 more questions to finish up the quiz. Some of you need to know the derivative of cosine is negative sine. You had your notes in front of you when you did this. Perfect. You did? How you doing? Nice to see you.
Yes, the product.
Do you see more than one variable? No. So it's just a chain rule.
You just sounds like suggested.
Sure. You would think of it as the cosine of u, and u would equal 4 minus 3t. So what's the derivative of cosine of u? Negative sine of u. And what's the derivative of the expression u with respect to t? Negative 3. Yeah, so it's going to be negative sine of u times negative 3. Negative 3 sine of...
Yeah, but 2 negative
Right. Well, yeah, in the end. So you end up with negative sine of 4 minus 3t.
You changed it from an F to a K.
Oh, sorry, that was a copy and a paste. F, T. There we go.
Get these now.
Fantastic. F, T. And that would be it. There's nothing to factor. There's nothing to do with that. And there is no product rule because there's only one variable. Okay? I wish I remembered how far we were supposed to go on this.
I think you said 30. Look online.
I'm getting ready to. All right. Go ahead and jot this one down. I'll check online real fast how far we're supposed to get. Some of those people on the advanced bio trip don't get shortchanged. I can do this on the Z drive. Calculus. Let's get through 41 today. So we're almost there. No. A couple more. Yeah, just a couple more, and then we're there. So what's the derivative of cosecant? Chase?
Negative cotangent x secant x.
Right. Negative cotangent, cosecant, and the angle stays the same. So that's the first part. Now what's the derivative of the inside? 2z. And I think that's it. There's not much else you can do. Or you can bring the 2z out in front. Sometimes people do that so they don't get confused that that's not supposed to be the angle. But remember, this is an angle theta, and the other one's just a number. So there's a difference. Negative cosecant, cotangent, right?
Yeah. It's not negative cotangent secant.
Now you can say negative cotangent, cosecant. That's fine.
Maybe I just forgot all my rules.
So we're almost there. Just a couple more, and we'll be there. So that's the trig ones. Those look like product rules, but they're really not. There's only one variable. Ooh, this one. This is a fun one. It is.
So what are we going to do?
41, so we can either stop here or do one more. Okay? You're right. Sorry? How do you think of this one? If you put it in the calculator, how would you put this one in the calculator? No, you wouldn't. Yes, you would have the tangent of 6w cubed. So you have to do the chain rule. You're going to have 3 parts. You're going to have the derivative of the cube. You're going to have the derivative of the tangent. And you're going to have the derivative of the 6w. And then you multiply those 3 parts together. Remembering, until you get to the end, the inside doesn't change. Another way of looking at it is how the textbook does it. They introduce another variable. Sometimes I do, but this is about the only slide you'll see me all year do this for the chain rule. I don't know, it's just a slow processor. They say think of it as y equaling v cubed, v equaling tangent of u, u equaling 6w. I think of it as parentheses, separating the functions. And this is their 3 different things. I showed them to you using parentheses. This is how you look at using calculus notation for the derivative of y with respect to v, dv, du, du, dw. When you're on a test or doing a problem, I don't think you're going to think of it as dy, dv, dv, du, du, dw. Some people do. I think you're going to think of it as, what's the derivative of a cube function? Yeah, 3 something squared. What's the derivative of tangent? Secant squared. And what's the derivative of 6w? 6. And then you're going to fill in the missing parts as you go. So the derivative of something cubed is 3v squared. The derivative of tangent is secant squared. I got secant tangent. It should be secant squared. Oh, I'm on eraser. What is she doing here? She needs to leave. Get out of here. All right. Secant squared of u. And what's the derivative of 6w? 6. Okay? You'd fill in tangent of 6w for the v, right? And 6w in for the u, and then just times 6. That would be secant squared of 6w times 6. So your final answer would be 6 times 3 is 18 times tangent squared of 6w secant squared of 6w. That'd be your final answer. So you can think of it like this, or you can think of it as something cubed, tangent, something else, and 6w. Because I would think of it as an extra set of parentheses right there. In algebra, you work from the inside of the parentheses out. For the chain rule, you work from the outside of the parentheses in from left to right. Okay? All right. And I always equate it to how I would type it in on the TI. So we're going to just go to 39, and then we'll finish it up on Monday? All right. So, all right. Somebody's going to say, you didn't say what the homework was. All right. 39, we said. Odd. Where do we start with? 21? 17. All right? 144. All right. See everybody on Monday. All those that were gone. Nice. See? I gave him a shout out.